So that's what we have happening in part A of this problem. When we're traveling north, we get to use the Pythagorean theorem, which is a common sort of thing to use in these types of problems. Anytime you have a right triangle, it's a fair thing to use. Now, for this other part B that I have listed up here, so saying that they travel northeast. So let's go ahead and draw the picture there. So again, we have the car traveling 50 miles per hour due east, but now we've got a car going northeast at 60 miles per hour. And so, and I maybe exaggerate this a little bit to illustrate the point that we are going to need a different tool here because this is not a right triangle anymore. So we are going to need some other way to think about and write an equation relating these two things. Now, conveniently, we do know what this angle has to be. This angle is 45 degrees because that would be our difference between northeast and east. And we also remember stuff that we learned in trigonometry, and we remember that we have something called the law of cosines. So if you have a side angle and a side, you can use the law of cosines to figure out this other side. And I'm going to call it C here. And so the formula from that was c squared is equal to a squared plus b squared minus 2 times ab times the cosine of c. Now, with the way this problem is written, I can call this side A and this length B, and this is my angle, big C. So we can go ahead and substitute that value in. And this will be the cosine of 45 degrees. And we could clean that up a little bit because the cosine of 45 degrees is the square root of 2 over 2. And if we further go here, this is c squared equals a squared plus b squared minus 2ab. And when we do that, it's just have a square root of 2 out front here. So now we've sort of rewritten everything, and now we're in a position to be able to write and take the derivative with respect to both sides so that we can get our related rates here. And so remember, the thing that we're looking for will be dc dt here. So as we take our derivative here, on the left we get 2c times dc dt. On the right we will get 2a times dA dt plus 2b times dB dt. Now, on this next bit, we're going to have to be a little bit careful because this is actually, with respect to t, a product rule. So if we'd have to take and leave a alone and take the derivative with respect to b, so that would be dB dt. So square root of 2 times a times dB dt. And then we do the same thing where we leave b alone and take the derivative of the first thing. So we get dA dt here. And now we are close to a position where we can answer this. So things that we were given based on the setup here. So dA dt is this 50 miles per hour. dB dt is our rate of change along there. The thing that we actually want is dc dt. So that means we need to use the information that we are given to figure out the remaining things. So we need to figure out C, A, B, and in that way. Well, again, we can figure A and B out because we know that the cars have been traveling for 2 hours. So after 2 hours, the car has traveled in my A direction is 100, and in the B direction will be 120. And we have that this is 45 degrees. So we can go ahead and figure out what C is from this. So using the formula again, so we have C squared will equal 100 squared plus 120 squared minus 2 times 100 times 120 times the cosine of 45 degrees. And if we wanted to approximate C from this, it would be about 86.2. So now we can take all this information and go back and plug it in and figure out our dc dt that we wanted. And I'll use our approximation here for C as we go here. So we have 2 times 86.2 times dc dt equals 2 times 100 times 50 plus 2 times 120 times 60 minus square root of 2 times 100 times 60 plus 50 times 120. And actually, if we had just left it as a square root back there, it would have turned out pretty nicely. So as we divide on the left to get dc dt alone, we get dc dt will equal 24,400 minus the square root of 2 times 12,000. And we've got this 2 on the bottom here, and with the radical 24,400 minus the square root of 2 times 12,000. Now, since we have the same thing under the radical that we have in the numerator, that's just going to cancel rather nicely. And so what we get is the square root of 24,400 minus the square root of 2 times 12,000 all over 2. And when we do that, we get about 43.1.